Today I'm going to be talking about geometric and power series. An infinite series is a series where we add up all our terms infinitely and our function goes to infinity. So we start at some value and then the sum goes to infinity of all of our terms. Partial sum is if we just add up the first two terms, second two terms, or n number of terms. A series converges if I'm able to find a sum, and the series diverges if we're not able to find a sum. That's kind of our goal throughout this entire chapter, is to figure out if a series converges or diverges. So our first example, find the sum of the series if possible. So I'm going to start plugging in n equals 0, so that's 1. If I plug in 1, I get 3. If I plug in n equals 2, I get 5. And I keep getting larger and larger numbers, so that means it is not possible to find a sum of this series. And I just kind of want to look at this limit as n goes to infinity. If we looked at the limit of the function, that goes to infinity. So I wonder what that all could mean. Find the sum of the series if possible. So I want us to look at this. And I want us to notice something. So I start with that, and then I'm going to add in if 2 was, now if I plug in 3, and then I plug in 4, and so on, notice how these numbers keep getting smaller. Notice how, what am I multiplying by? I'm multiplying by 1/10. Multiplying by 1/10. So this is what we call a geometric series, where I'm multiplying by a common ratio. And if you remember, back from Algebra 2, the sum of a geometric series is your first term over 1 minus the ratio. So let's look here and see. Our first term is 3 over 100. Our ratio, I keep multiplying by 1/10. So our sum is going to be 3 over 100 divided by 1 minus 1/10. That's 10 tenths. So I get 3 100ths. That is 9 tenths, so 10 ninths. So I get my sum is 1 over 30. Now let's just look again at the limit of the function that we're trying to find. If I find the limit of that function, that limit goes to 0. So this converges, and it converges to a certain value. And this comes off of what we talked about a little bit in chapter 9. Okay, so a geometric series, like I just talked about, is you have your first term, and then you have a common ratio that you keep adding in. The series converges if your ratio is less than 1. Another way of saying that, if your ratio is between -1 and 1. And it diverges if the ratio is greater than 1. In the interval of convergence, so there's a function this function here, this is the function that I can actually write for a geometric series. So it's going to converge this series. If I put all these terms into like y1 in my calculator and put this function into my calculator, the interval of convergence is going to be if r, or whatever my ratio is between -1 and 1. And we'll go through an example of that. Okay. First example here, A. Find the sum of the series. I know it's geometric because I have n-1 in my exponent. So my first term is equal to 5. My common ratio is 1/2. So I have first term over 1 minus 1/2. That all simplifies to be 10. Here, my first term is, if I plug in 1, is 3/5. My ratio is also 3/5. So I have 3/5 over 1 minus 3/5. So I have 3/5 times by 5/2. This is going to simplify to 3/2. Now let's look here. Here, my ratio is -π/2. Here, my ratio is a π/2. Remember, pi is 3.1415 whatever divided by 2. That's going to be some number greater than 1. So that diverges. Now, something back in my day that we used to have to do is we used to have to write this repeating decimal as a geometric series. So let's look at this. And so on. And what that means is that's 0.08 plus 0.0008 plus 0.0, what do I have? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 8. So this technically is a sum. What is this? This is 8/100ths is my first term. My ratio is 100th. So this is the sum, n equals 1 to infinity of so that's what that would be as a geometric series, but let's actually write that as a fraction. And let's use this piece here. So what do I have there? I have my first term over 1 minus 1 over 100, which is 8/100ths over 99 over 100, which that simplifies to 8/99. So this is where that interval of convergence comes in. So you see here that I have 5 times something. So if I were to plug in n equals 0, our first term would be 5. And then I would just keep multiplying by this x plus 3. So our ratio is x plus 3 over 2. So the interval of convergence means that ratio needs to be, I need to write the whole ratio, needs to be between -1 and 1. So we need to solve that inequality. So I have -2 if I subtract 3, I forgot to subtract 3. And let's find the function of x, meaning our function comes from here, comes from this sum of this. What is the sum? The sum is the first term over 1 minus the ratio. So if I multiply the top and bottom by 2, just to simplify it out a little bit, I get 10 over 2 minus x minus 3. And that is going to simplify to 10 over negative x minus 1. So this is my thought to you, is if you were to write this out, so 5, if you were to write out that series would be 5 plus 5 times x plus 3 over 2 plus 5 times x plus 3 over 2 squared plus so on. So the more terms you write out, and say if you graph that in y1, and you graph this in y2, I think that this series and that series are going to be basically lying right on top of each other for our interval of convergence. Okay, that's all I have for you today. I'm going to do another video here in a minute that talks about power series.